happening here is we have to figure out what's called how do you undo things. Okay. I want to think of this as in an equation. In an equation like this, where it just says x plus 2 is 7, what do you do? Why do you subtract? Okay. You have to subtract the 2 to get x by itself. Because isn't subtraction the inverse operation of addition? You guys okay with that? Inverse operation? Does that ring a bell? So I would subtract 2, and x would equal 5. Okay. Now, what if it was, what would you do now? But again, division is the inverse operation of multiplying. You guys okay with that? Okay. Now, dividing by 3, writing it like this, I get 7. Now, for those of you that have the calculator out by chance right now, open that up real quick. And I'm going to go back and re-look at this idea of 3x equals 21. In your calculator, there's a button that looks like this. Everybody see that one? Oh, no, there should just be a regular, it's right next to, it's right above the 7. Oh. So, it's right above the 7. Now, I want to show you what happens. What I want to do is hit 3, just for a second. If I hit button 3, and then I'm going to hit that to the negative 1 power. Now hit enter. What does it give you? 1/3, isn't it? Now, go back to the problem we just looked at. When I divided it by 3, isn't that the same thing as saying times 1/3? Because if you divide by 2, what's 10 divided by 2? What's half of 10? Same answer, isn't it? Depending on how you say it is how you would write it up. So this is the same basic idea here. What we're doing is we're still doing this to both sides of the equation. But in essence, what it is, this negative 1 power stands for inverse. Okay? It stands for an inverse. All right? Now, you were saying a second ago above the sine, cosine, and tangent buttons, you saw that there was a negative 1 button. Those buttons are the inverse trig functions. We utilize those when you don't know the angle. Okay? So, for example, if we draw a quick little triangle, and this time I'm going to put a theta here, but I'm not going to give it a numerical value. Then I'm just going to put a 5 and a 12. This question is asking us to find theta. What do you think we do first? Yes. Circle theta. The steps aren't here. The steps still follow the same rules. Okay? Now, when we circle theta, just like we have been, I draw my opposite, I label it, I label this, and I label my adjacent. And then at this point, we're at which trig function? Which trig function has opposites and hypotenuse? Sine. Okay? So we're still following the same lists here. Circle, draw and label, 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 which trig? We're at sine, but I don't know what my angle is, so what do I put there? Theta. But what does it have to equal? What fraction? 5 over 12. Okay, that's wrong. Theta? You use theta for when you're talking about an angle instead of using x. All right. It's the Greek letter. I think it was alpha, beta. Yeah, alpha, beta, theta. I don't know. It's one of the letters. Pythagoras? A lot of modern math came from Greece. All right, that's where most of the modern math came from Greece, and a lot of it's also in Arabic too. So, all right, so at this point we're here.
It hurts.
They do what to her?
I don't know.
Anyway, back to this one. I gotta get theta by itself. So think about it this, go back to what we did a second ago. We had 3x equal 21. To get the x by itself, we, in essence, use the inverse of multiplying. So remember when we did that, we basically, if I did this, 3 to the negative 1 to both sides, that meant 1/3, meant divide by 3. Does that make sense? So what happens here with sine, or cosine, or tangent, whenever you need to find the angle, this is how this goes. If you're finding an angle, you have to use the inverse of your fraction. When you're solving for an angle is when you use the inverse function. Now, in the calculator, we would press buttons. All I want us to do is write this. To move this to the other side, you inverse it. Because remember, anything to the negative 1 power is 1 over it. So if I go back here real quick, and if I'm writing 3x equals 21, if I do 3 to the negative 1, this equals 1/3. 1/3 times 3 cancels each other out. Same idea here. If I say the sine of something, and I multiply by sine to the negative 1, this means 1 over. What's anything divided by itself? 1. That's how this undoes itself. But since numbers are jealous, you just have to do it to both sides. That's why we keep things balanced. Right? That's where that inverse property stuff comes from. So in this case here, and today I'm not going to worry too much about pressing buttons. I'm just going to show you once or twice, and then I'm not going to worry about it. In the calculator, you would have to do this. Second, sine. Notice how it opens parentheses right away? Then you would put in your fraction bar, 5/12. You don't technically have to because you're not doing anything after it. But if you want to get in the habit of doing that, that's fine. Okay. Question was, do you have to close the parenthesis in this case? You don't, because you're not doing any calculations after this. Okay. And hit enter. There's your angle. And then you would round it to how many decimal places? 2. Right. Again, is this any more difficult than what we were doing? No. The only thing that's weird is that you have to remember the inverse in it. Okay? You have to inverse it. That's how you get the angle. Right? A lot of you guys will forget the inverse button, you'll wind up with errors and things like that. So that's why we start by always writing it out. Okay. Ouch. All right, let's try another one. Once again, we've got our right triangle, and I'm just making up sides right now. Okay. We follow through the process just like we have been. Circle, draw a label, 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 which trig. By now that's pretty much ingrained in our brains. Circle, opposite, hypotenuse, adjacent. And you said which trig was this? Candy. Everett.
So when you're finding the angles, when you're trying to find out which trig it is, you're using the two sides that you already have.
Yes, ma'am.
Because, well, the other one, you would use the side that you're looking for and this one side that you have.
Correct. And that's as we build into it more so next week, those are the decisions you'll make. Because honestly, you're either going to know two sides, or you'll know one side, one angle. If you know two sides, you have to find the angles. If you know one side, you have to find the other sides. Okay? And that'll fall into place like a flow chart of what do you know, where do you go, that kind of thing. And we'll get to that next week. But yeah, it's exactly right. What trig function do we use? Very good. Tangent. So we have the tangent of theta. Remember, we're using theta for our unknown. And then opposite is 13, adjacent is 6. How do I move the tangent? Remember, it's the -1. Yeah. So theta will equal the tangent inverse of that. Okay. It's okay. It's okay. So let's add that as part of one of our things. So if solving for theta, remember you're going to have some trig of theta equals some number divided by some number. All right. When this happens, to get theta by itself, whenever you're trying to find it, you're always going to do the same thing. Theta will equal whatever trig function it is to the inverse of the number divided by the other number. Okay? Your trig functions all still mean the same, still opposites, hypotenuses, and hypotenuse? I think it's hypotenuse. Whatever. The hypotenuse and the adjacents, they're all still in the same positions. They're all still found the same ways. The only thing that's different is that at the end, if you are trying to find the angle, that's how you get theta by itself. All right? That's the only difference here today. All right? I know it looks weird, but in essence, it's, speaking of weird.
So wouldn't you like the X on the top of the bottom?
No, when we're trying to find the angles, that means we know both sides. Okay? So this is when you're trying to find an angle, then you'd have both numbers. You couldn't find the angle if you don't know. If I only knew one side length and no angles, I couldn't do the problem. I don't have enough information. I have to have 2 bits of information to make that work. I have to have 2 sides, and I can have any of the two of the 3. Okay, any of the 2 of the 3, because there's only 3 possible combinations that you could use, and that's how you figure out which one you're going to use, just like we did before. So all the setups and everything else goes the same. The last little bit is how do you set it up to get it by itself, okay? And that's where it just gets weird. That's why we want to make sure we understand how to set it through. Right? Let's try to. I'm not worried about it. Oh, I know how to set it up. Oh. What was your answer, Miss Fancy Pants?
He's not wrong. It's 65 for 22. I think it's the
What?
over. What does it say? I don't know what that is saying.
Other number.
Oh. Sorry.
Yeah. How do you spell theta? Theta? Theta. You know what? Other people have asked that also. You spell theta. Theta is spelled T-H-E-T. Theta. 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 T-H. Theta. Theta. I've got half a fake front tooth, so it's very tough for me to say. Theta. So you're thinking this? Isn't that a cheese?
I envision it.
Or are you rating it as fate?
No, I really read it as feta.
This was a joke. I was like, fate, or, oh, my fate, Okay. Once again, start with the right triangle. Go through your steps. Actually, our steps, instead of at 6 where we said set up the solve for x, I'm going to put in or theta. Because now we have theta for the missing angle. I believe today, the CUDA sheet that I used, that I made for you guys real quick, they don't put a theta here, they just put a question mark. Is that all right? Bless you. Bless you. I'm sorry you're allergic to trig functions. Please. I know. Maybe it's you. She's probably allergic to you.
I don't even say much. Oh, crap. That's
What trig function would we use to solve for theta this one? Cosine, very good. Cosine. Cosine is 13 over 73. And then to get theta by itself, we would just move it over. Theta is the inverse cosine of 13 over 73. Once again, these numbers, the decimal values and all that stuff as you go through it, they're really not going to make a ton of sense to you guys as far as what they mean, are you even remotely close. That's why all I want you to do is not worry about pressing buttons on any of this stuff right now. I just want you to set them up. Yes, ma'am?
Why?
Because it's called an inverse. You missed that when you were finishing up your quiz. Remember, if you have your calculator real quick, bless you. Type in 2, and then see the button above the number 7 where it says x to the -1. And then hit that, and then hit enter. So it gets 1/2. What happens is, what we're doing in so many terms is if I want to undo the sign, whatever this is, okay? If I want to undo the sign, I have to do the inverse operation. Well, the inverse operation would be sine to the -1. That means 1 over sine. Those signs drop, but since I did this to one side, I have to do it to the other side. So then that's where this comes into play of the inverse of that value. And that's how you generate theta. So that works anytime you're trying to find theta for any trig function, you use the inverse one. And that's where the -1 comes. Does that make more sense now?
Yeah.
All right. Let me give you a few of these to try out for the site tonight. No buttons, please. Don't press any buttons. All right. I don't want to worry about buttons. I don't want to worry about any buttons at all. I just want to see setup. I want to try them out. Okay. We'll worry about button presses and stuff like that tomorrow. Okay. I'm not worried about it. I want to take my time. I want to make sure we set them up right.
Keep that in mind. I don't like that. I don't like
So, what's that? So, in this one here, this should be pretty straightforward, all right? All I want you guys to do is to write out everything like we have been before you would do it to the calculator, okay? So, if I'm looking at number 1, for example, on number 1, we have the right triangle. The question mark is here, so that's our theta. So we would go through the process just like we have been. We always start circle, label, hypotenuse, adjacent. What trig function is opposite adjacent? Tangent. Okay? 5. And 0. So you have to use tangent. All right. So we would write it out, just like you did yesterday or 2 days ago before we pressed any buttons. So we have the tangent theta is 9/36. Lastly, what would I do? Inverse, very good. I'd write as theta is the inverse tangent of 9/36. And I leave it. I don't press anything. I don't do anything with it. Because here, if I see this, I know you know what you're doing. Okay? That's the idea. All right. When we get to Friday, and I don't know if you guys saw this on the board there, we will do a very brief, easy quiz on this stuff, and it should be really good for all you guys. It's going to be a handful of solve for x or side length. It'll be a handful of solve for angles. Okay? That's all we're doing, and we have to show what we're doing. Okay? What's up? Nope. You gotta know it. Gotta know it. It's so tough to remember the word SOHCAHTOA. All right, I remember it. What's up? Yeah. Shouldn't take very long. It's pretty easy. Yeah, that's on top. Yeah, no shit. I'm sorry I ruined your day. Did you get over it today, though? Should I play it right now, then?
No.
I feel like ruining your day.
I'm having a great day.
I feel like you should ruin your day.
No, that's.
Yep, that's me. Perfect.
No.
No. There's that one, and then what's the other? There's another song I forgot.
Wait, are we doing both sides?
Yes, ma'am. Should not take very long. Remember, guys, always write out what you're about to do before you do it. That's the easiest way to make sure you're doing this correctly. All right?